Hello and welcome back to our channel Artezmia for another video about electronics. This episode is a sequel to the previous one, and we will explain how our last circuit kinda worked when it was not supposed to, and in any way did not work as it was intended. After watching this video, this will make sense to you. So if you haven't watched the previous video, please watch it before watching this one, as I will continuously refer to it. I was starting to be interested in playing with surface-mounted devices, or SMDs. So I went onto AliExpress website and started exploring this new world and switching back and forth between shopping and looking at data sheets. I observed that with SMDs I could find MOSFETs much closer to my specs than the through-hole ones that were mostly TO220 packages handling 60 volts and up with 10 amps and up, when I need really 12 volts and if I'm lucky 1.5 amps. So I bought a bunch of MOSFETs and NP channels, the latter being more difficult to find, and adapters so that I could experiment on a breadboard. As it is quite difficult to handle, at least solder the tiny SO23 chips on the adapter, the pads being 0.95 millimeters apart, I had to buy a headband with magnifying lenses and light, and I was fortunate enough to be lucky and buy a decent quality one on AliExpress. I was anxious to try the little things, so I went to the circuit I had done on a breadboard for the last video, unplugged the MOSFET, and plugged the thing with DuPont wires, and I could see, surprise, that it was always on with both MOSFETs. So I started to think that my soldering was not that great after all, and I started to look on the web on how to test a MOSFET. I found an interesting page, see the reference in the comments below, and build a circuit to test the MOSFETs on a breadboard, of course. And I started testing the one I had on the board, the one that did work. Well, it failed the test, with apparently a short between drain and source. I checked my circuit, changed a few resistors for other values, tried again, same thing. I built the same circuit as in the article, except that I'm using 12 volts instead of 5 volts to power it, as all my circuits work with 12 volts and I'm not going to destroy anything. Then I tried my new MOSFETs. One of them worked the way it's supposed to, and the other had the same flaw as the TO220 MOSFET that worked on my previous board. Then I realized that on my circuit before triggered, the voltage out of pin 3 of the 555 is 0. Which means that the gate of the MOSFET is at 0 volts, and since it's a P-channel, it is supposed to be on. So why was the circuit in my previous video working? I just changed a P-channel MOSFET for another one, and it was working fine even though the voltage at the gate was 0. Then I remembered that I was a little bit puzzled when I was building the circuit, and it looked like drain and source were switched. But I didn't think much of it. Maybe it was something of the Chinese copycat manufacturer. I didn't know. I went once more to the datasheet on alldatasheet.com, and sure enough, the big characters caught my eye. P-channel logic level enhancement mode field effect transistor. So what is that logic level all about? I did some research, and obviously these MOSFETs are not the same as plain P-channel MOSFETs, and the circuits to use them are different. That's why the supposedly plain P-channel MOSFET failed the test circuit. Then I checked the datasheets of my new SMD MOSFETs, and sure enough, the one that failed the test was also a logic level MOSFET, while the one that passed the test is a plain P-channel MOSFET. I realized I was lucky when building the circuit in the previous video that it would work. The other thing that had caught my attention then was when I measured the voltage between the pins of the siren when the alarm was triggered, I was getting very close to 10 volts and not close to the 12 volts, which is my VCC, and I was wondering why. Now I have the answer. It's by design with the logic level P-channel MOSFETs. So I was back at the drawing board trying to modify the circuit to work with a plain P-channel MOSFET. The solution boiled down to the following. I need a component or circuit that is fed VCC and V3, that's the output of pin 3 of the 555 timer. This component has to output VCC if V3 equals 0 and V3 if V3 is different from 0. I must have been tired because it took me all of 10 minutes to figure out, well, that's what a transistor does. Since I came to believe that MOSFETs are better than BJT transistors, I picked one of my 2N7000, added a couple resistors and a few more DuPont wires, and sure enough, it worked. I'm not going to build a working board with these changes. I did, however, update the drawing and also got rid of the LDO that I explained last time we could do without. Here it is. I forgot to mention the references of the MOSFETs. The original one that I used that was a logic level MOSFET was an NDP6020P, and the new SMDs one are an SI2301 and an IRL-ML6402 TRPBF, the first L being for logical. Now here's the circuit working. I don't have internet in my house at the moment, so the D1 Mini gets stuck trying to send a telegram message to my phone and the relays don't start flip-flopping until after that's done. I will revise my code so that doesn't happen. I also measure the voltage, first V3 at the pin 3 of the 555 timer, getting over 10 volts, that's the white wire, and then at the high pin of the siren, that's the green wire, and I get 12 volts, which is a lot more satisfying than the 10 volts I was getting with the logic level MOSFETs. I decided to put the logic level converter below the D1 Mini. Not only does it save space, but also it is a lot more practical to do the soldering. Check the previous video for the color codes. Obviously, the coding for the D1 Mini hasn't changed from last time. Please refer to the web page mentioned in the previous video. For those of you who might think the previous video was misleading, well, in a way it was, but it was with no intention. I'll remind you that I started on this journey of learning electronics about 6 months ago, never having heard of a breadboard before, least held a soldering iron. All of us do at one level or another. We're all learning as we go. I share my experiences so that others can go a little faster up the learning curve. This is it for now. If you watched this episode up to here, or if you found it even remotely interesting or entertaining, please hit the like button, subscribe, and leave a comment below. All comments are welcome. See you soon for another episode.